Welcome back, Algebra. We are in Chapter 2, Section 6 today, Divide Real Numbers. Our first concept today, reciprocal. If I ask you to find the reciprocal of 3/4, can you do it? Don't say it out loud. Keep it quiet. Let's say it together. The reciprocal of 3/4 is 4/3. Good. And an interesting fact about reciprocals is when you multiply a number and its reciprocal together, what do you get? Let's see. With multiplication, we simply multiply straight across the numerators, right? And the denominators. So 3 times 4 is 12, and 4 times 3 is also 12. And we can simplify that fraction. 12 over 12 equals 1, right? So when we multiply a number and its reciprocal, the product is 1. Two numbers whose product is 1 are reciprocals. Don't forget to pause the video if you need more time, right? So when we were discussing the properties of multiplication, we talked about our multiplicative inverse, right? Our multiplicative inverse says that when we multiply by the inverse, we're multiplying by a reciprocal. Keep in mind that we find reciprocals of non-zero numbers. We'll talk about that in a second. But as a rule, we can say A times its reciprocal. So the reciprocal of A is 1 over A. Good. Equals 1, right? These are multiplicative inverses. Keep in mind, A may not equal 0. So whenever we see a variable in the denominator, we will see this little rule that A may not equal 0. What if A equals 0? What do we call that? That's right, undefined. Dividing by 0 gives us an undefined expression. Okay, here is your first question for today. Find the multiplicative inverse of the given value. So quietly find the inverse of these two values, quietly, and then we'll say it together. Pause the video, come back. Okay, the inverse of 9 is 1 over 9, that's right. And the inverse of negative 5/6 is negative 6/5. Okay, very good. Okay, so when we were working on addition and subtraction, we found that we could change all of our subtraction to addition, right? By just simply adding the opposite, okay? Today we're going to find that that same thing is, that's related to this division rule. We can change all division to the inverse of division, which is multiplication. It's interesting. By using our reciprocal. So let me give you a little example. If we have 8 and we're going to divide that by 4, you all know what 8 divided by 4 is. Simple, simple, simple. It's 2, right? But let's see. We can rewrite this as a multiplication expression, right? We could say this is 8 times the reciprocal of 4, right? Which is 1 over 4. Good. And again, what's the denominator here underneath the 8? Well, it's 1, right? That's just a regular integer. So when we multiply across these fractions, we know that 8 divided by 4 is 2, right? So let's see what we get. 8 times 1 is 8, and 1 times 4 is 4. So, yay, we have 8 divided by 4, which, of course, equals what we knew it did, and that's 2. So we may change all division to multiplication of the reciprocal. To divide a number, A, any number, by a non-zero number, B, multiply by the multiplicative inverse of B. A divided by B is the same as A times the multiplicative inverse. Yay! Okay. So we can write this in the form of a rule, showing our old division symbol, A divided by B equals A times the multiplicative inverse, which is 1 over b, right? Which equals, in this case, a over b. All right, so now that we know the division rule, let's recall what happens when we use positives and negatives. I mean, a positive divided by a positive gives us a positive, right? But what about a positive divided by a negative? What if I change this 4 to a negative? Over here, we could put the negative in the denominator or the numerator, right? So let's put it in the numerator to make it interesting. So we have a times negative, 8 times negative 1/4. A positive and a negative together gives us a negative, right? So the same rules apply as have in the past. The signs will be, the quotient of two numbers with the same signs is positive. The quotient of two numbers with different signs is negative. All right? And finally, the quotient of 0 and any non-zero is neutral. In other words, 0 divided by any real number, a, would equal 0. 0 divided by, let's say, 2 equals 0. This is a true statement, right? We can say that. However, the quotient of a non-zero and 0 is undefined. So this is saying, how about a divided by 0? Oh, you can't lay this stinky egg, right? A divided by 0 is undefined. Whenever you find a 0 down underneath that division bar, we have an undefined situation. Okay, let's try a few examples together. So we have negative 14 divided by 2.5. So this always can be tricky because it's a mixed number, right? So see what you can do and come back. All right, so we have negative 14. We want to change this to multiplying by the reciprocal, right? So first we've got to get this mixed number into a improper fraction. So 2 times 2 is 4 plus 1 is 5, so we have 5 over 2, right? Good. Now we have a fraction that we can find the multiplicative inverse of. So we have negative 14 times, flip it over, 2 over 5. Right? Now we have a negative being multiplied to a positive, so we're going to have a negative product, right? And we end up with 14 times 2, so we have negative 28 over the denominator of 5. Running out of room here. Okay, very good. And we could change this back to a mixed number, can't we? So 5 goes into negative 28, negative 5 times, and then we have 3/5 left. Very good. Okay, have you given number 2 a try? Negative 3/4. This time we were dividing by negative 4. What is the denominator of negative 4? 1. Good. So we're going to multiply by the inverse, which would be negative 1. The negative can just stay in the numerator over 4. Good. And so now we have a negative times a negative, which is a positive. We have 3 over 4 times 4 is 16. Good job. 3/16. Let's try number 3. Okay, so number 3 is super tricky. We have a big expression in the numerator and one little monomial in the denominator. So give it a try and come back. Okay, so if you're back, I hope you are understanding that this whole numerator is being divided by negative 3. So remember, we talked about this last year. We're distributing the division to both terms. So this could be rewritten as 9x over negative 3 minus 15 over negative 3. Okay, good. So now let's change the subtraction to addition of the opposite so we don't lose track of things, right? Okay, so now we can treat them each separately. 9 divided by -3 will give you -3, won't it? -3 times -3 is 9. So -3x here, and then we have -15 divided by -3, which is +5. Very good. So keep in mind the number one error here would be dividing only one of these two terms by the -3. Often people just divide the first term, and that's an error. This entire numerator has to be divided by that term. So go ahead and try number 4, and then come and check your work. Once again, both terms are being divided by 5. Both of them. Okay? So we could rewrite this as -8x over 5 plus 12 over 5. And you know what? 5 doesn't go into either of these very easily, does it? If we were to change this to a mixed number, it really wouldn't simplify this expression much. I mean, to say -1 and 3/5 x, ooh, that's complicated. Plus, what, 12 divided by 5 is 2 and 2/5. Again, that doesn't simplify things very much. So actually, this term could be left this way, and that could be considered the simplest form. -8x plus 12 over 5, since 5 cannot easily go into 8 or 12. All right, so kind of interesting. When it can go in, like in question number 3, we can simplify this to -3x plus 5. It's nice and simple, right? But when it can't, this is not a simpler statement than the original. So we could leave it in the original form. All right, here, enjoy one of your final workbook assignments, and be good. Bye.